Hi Nancy, my name is Jacob McGrath and I am applying for the physics tutor position from Nancy STEM Education. This is the video portion of my application. With this video, I will answer the question of a block is pushed up a rough incline with an initial velocity, and the incline makes an angle theta with the horizontal. The block comes to rest after moving a short distance without sliding back down. What must the coefficient of friction be between the block and the incline for this to happen? I'm going to answer that question with this video. So, gravity is obviously trying to pull the block down the incline. And this is the component of the gravitational force that is parallel to the incline, and it's trying to pull the block down. But then the force of friction acts opposite on the block, opposite in regards to the force of gravity, and the friction opposes the force of gravity and keeps the block there. And obviously the block will remain at rest if the force of friction is greater than this gravitational force, or if it is equal to this gravitational force. So if this frictional force is equal to this gravitational force, the block will stay there. If this frictional force is greater than the gravitational force, this block will stay there. So we need to figure out the coefficient of friction for when this frictional force will be greater than or equal to the gravitational force. So first, I'm saying that the force of gravity will be denoted as Fg, which is the mass of the block m times the acceleration of gravity g. So force is obviously mass times acceleration, so it's mass of the block m times the acceleration of gravity g. The normal force will be denoted as N and the component of Fg that is parallel to the incline will be denoted as Fg parallel, and the component of Fg that is perpendicular to the incline will be denoted as Fg perpendicular. The maximum static frictional force will be denoted as F max. The coefficient of friction will be denoted as mu. So, first of all, let's figure out what the component of the gravitational force that is parallel. Let's figure out what this is. Let's figure out what the parallel component of the gravitational force is. And here's a force diagram. Here's the block. This is the force of gravity pulling straight down on the block. But the force of gravity has a parallel force, a force that is parallel to the incline, and it also has a force that is the force of gravity has two components. One component that is parallel to the incline, and one component that is perpendicular to the incline. And I made a triangle of the gravitational force. And I've determined that this angle theta, or that this angle is also theta. This is obviously theta because this is the incline, but this is also theta. And I've determined that because of these triangles. Let's imagine that this is 30 degrees. Let's imagine that theta is 30 degrees. This is obviously 90 degrees. So this would be 60 degrees. And this is a right angle, and this is a right angle. So obviously this angle has to be 30. So therefore this angle is equal to this angle. Because in any triangle, angle A plus angle B plus angle C is equal to 180 degrees. That's why, since this is 90 degrees, and if this one's 30 degrees, then this has to be 60 degrees. And then this has to be 30 degrees. Because 60 plus 30 is 90, and this makes a right angle right here. So this is theta, and if this is theta, then this is theta. Now, I'm going to take this force triangle and look at it over here. And so X is the component X is the component of the gravitational force that is perpendicular to the incline, and Y is the component of the gravitational force that is parallel to the incline. And I'm going to use SOHCAHTOA to figure out what X and Y are. So for X, I'm going to use CAH, which is cosine of theta is adjacent divided by hypotenuse, because X is adjacent to theta. So cosine of theta is the adjacent side of the triangle, which is X, divided by the hypotenuse, and the hypotenuse is the force of gravity. So adjacent divided by hypotenuse. So X divided by the hypotenuse is cosine of theta. So now we just solve for X. So the force of gravity times cosine of theta is X. And then we use sine of theta is opposite divided by hypotenuse. Sine of theta, so the opposite side is Y. So Y divided by the force of gravity is the sine of theta. Sine of theta equals Y divided by the force of gravity. So then Y equals the force of gravity times sine of theta. So the perpendicular force of gravity in regards to the incline is force times cosine of theta. And since the block is not moving in this direction, up or down, that means that the normal force must be equal to the perpendicular portion of the gravitational force. So the normal force is force times cosine of theta, because the perpendicular portion of the gravitational force is force times cosine of theta. And since the block is not moving in this direction, the normal force is equal to the perpendicular force of gravity, of the gravitational force. And so the component of the gravitational force that is parallel to the incline is the force of gravity times sine of theta. So this is the force that is trying to pull. So the force of gravity times sine of theta is the force that's trying to pull the box down the hill. And the normal force is the force of gravity times cosine of theta. And it's pushing up. The incline is pushing up on the object. And then the maximum static friction force is determined by mu times the normal force. And we just determined that the normal force is the force of gravity times cosine of theta. So mu times the normal force is mu times the force of gravity times cosine of theta. Now, let's look at the condition. So for the the condition for the block to not slide back down would be that the frictional force must be greater than or equal to the component of the gravitational force that is pulling the block down the slope, which is, as we discovered earlier, the force of gravity times sine of theta. So, the frictional force must be greater than or equal to the force of gravity times sine of theta in order for the block to stop on the incline and not move. Now what we have to do is substitute for the force of friction. So we put the frictional force in here, which we learned is mu times the normal force. And now we have to solve. So we'll cancel the force of gravity from both sides. Then we're left with mu times cosine of theta is greater than or equal to sine of theta. And then we'll just solve for mu. So we get mu is greater than or equal to the sine of theta divided by cosine of theta. And we know that the sine of theta divided by cosine of theta is equal to tangent of theta. So therefore, mu is greater than or equal to the tangent of theta. So therefore, in order for the box to not slide back down, the coefficient of friction must be greater than or equal to the tangent of theta. The coefficient of friction in the frictional force must be greater than or equal to the tangent of theta. So yes, in order for the box to not slide back down, the force of friction must be greater than or equal to the component of the gravitational force that is parallel to the incline. And in order for that frictional force to be greater than or equal to the gravitational force, mu, or the coefficient of friction, must be greater than or equal to the tangent of theta.
The reason that sine of theta divided by cosine of theta is equal to tangent of theta is because if we go back to this triangle, sine of theta is y divided by gravity, and cosine of theta is x divided by gravity. And y is the opposite side to theta, and x is the adjacent side to theta. So then looking at this, sine of theta divided by cosine of theta is y divided by mg divided by x divided by mg, which equals to y divided by mg times mg divided by x, which equals to y divided by x. And y divided by x is the opposite side divided by the adjacent side. So, and the opposite divided by adjacent, because of TOA, is the tangent of theta. So y divided by x is the tangent of theta. So that means that sine of theta divided by cosine of theta is equal to the tangent of theta.
Thank you for your time and consideration, Nancy. I hope to help high schoolers with their physics soon. God bless you.